Welcome to the lesson on congruence. In this lesson, we will discuss the basic ideas behind congruence and how to determine if two figures are congruent by specifically looking at examples involving triangles. Now, figures that are congruent have the same size and the same shape. Essentially, they have the same measurements. This means that all of their corresponding angles and sides are congruent. But what does it mean to have corresponding sides? So let's take a look at two triangles, triangle ABC and triangle EDEF. Now the corresponding angles would be angles A and D. These triangles look the same, but A and D are the ones that are the same. A doesn't have to be the same to D, E, and F, just E. Now C is corresponding with F, so C and F are the same, and B to E. So these two triangles have three pairs of corresponding congruent angles, and the same thing could be true for sides. Side AB is the same as DE, and side BC is the same as EF. Lastly, AC is the same as DF. And with these 6 pairs of sides and angles, we're able to write a congruency statement and say that these triangles are congruent. So I can say triangle ABC is congruent with a proper symbol of congruence. Triangle ABC is congruent to triangle DEF. And even looking at the statement, it's still worded in such a way that A matches with D, B with E, C with F, and even EF next to each other. The segment would match up with BC. But can we take a figure, can we take these properties and apply it to even a 4-sided shape? So looking at this example, I have these two quadrilaterals. Now they're oriented kind of funny. I can kind of maybe think that they're congruent. But how do I use these symbols? So A has one arc, so it would match up with the other angle that has one arc on the other quadrilateral, U. So A is congruent to U. Then angle B would be congruent to angle R. Angle C with 3 arcs would be congruent to angle S with also 3 arcs. And lastly, angle D would be congruent to angle T. Now, if I take a look at the sides, I notice that AB has 1 dash, and it would be congruent to UR that also has 1 dash. So segment AB is congruent to UR. BC would be congruent to RS. I look at my sides with 3 dashes. CD would be congruent to ST or TS. And lastly, AD would be congruent to UT. And I can go put segment lines on all of this and make sure that I make these properly congruent symbols. So I've identified everything that's corresponding. So let's use some of these principles to complete a proof. Let's say I have this diagram. To start a proof, I will go ahead and build my column. Then let's say I'll put statements on the right-hand side, and then the corresponding reasons on the right. Now, before I start, I know that I'm given a lot of things here in these diagrams, but let's go ahead and establish what I'm trying to prove. I'm trying to prove, beyond a shadow of a doubt, that triangle ABC is congruent to triangle DEF. Okay, so I can look at all the things I have and then determine, okay, well, do I have enough to prove that these two triangles are congruent? Let's start off with what might be given to me. I'll start off by knowing that AB is going to be congruent to DE, that BC is congruent to EF, and that AC is congruent to DF. These are all the things in the diagram. I can say all of those things in one statement and give a solid reason of given. So that's my first statement, those 3 items with the first reason of given. Now I was given some other information. I was given some information about angles. So I can say that angle C is 30, and I know that angle F is 30, so I can just go ahead and say that C is equal to F. And in that same way, angle B is equal to angle E. And because this information now is provided to me in this diagram, I can say that this reason is also given. So 2 statements, I've said 5 big things that were all given to me. Now I'm missing angle A and angle D. I wasn't given information about those. So I could imagine that if angle A is equal to D, I could prove congruence. Well, is that the case? So let's take a look at what we do know and establish and see where we can go. Well, I know that angle A plus angle B plus angle C should equal up to 180. Then go to the other triangle, and angle D plus angle E plus angle F will also equal 180. Now, I wasn't given this information. I know that simply because of the triangle sum theorem. That's a critical theorem that says all the angles in any triangle equal up to 180. So by using this theorem that I should know from the past, I can make my third statement. I can then replace B and C with their numerical values. So angle A plus 113 plus 30 equals 180. Angle D plus 113 plus 30 equals 180. And because I did replacing, I've used the substitution property of equality. Well, then I can solve both these equations for A. And when I subtract 30 and 113, I get that angle A is equal to 37, and that angle D is also equal to 37. And since I've subtracted, I call this a subtraction property of equality. So after subtracting, angle A and angle D are the same thing. So angle A is equal to angle D. And I can again use one of my very important axioms, or just a simple fact that two quantities that equal the same thing are equal to each other. And I'll just write two quantities there for short. Now that I've established the last pair of angles, I now know that triangle ABC is congruent to triangle DEF because I found 6 pairs of congruent corresponding sides and angles, and that is the definition of congruence.